In 4 places, the protons are deviated on a single trajectory in order to let them collide in the detectors. One of the new detectors, for example, will be installed here, 100 meters below ground, in a gigantic cavern linked to the surface by 3 shafts. Inside, the detector, 44 meters long, 22 meters in diameter, 7,000 tons of steel in circular layers around the collision zone. The computers linked to this experiment have to process the equivalent of 100 billion telephone calls per second, a real technological challenge. Whereas in the LEP, bundles of particles followed each other every 7 kilometers, in the LHC, they'll do so every 7 meters, millions of collisions per second. This is a scientific project on a world scale, which requires considerable financial effort, but which is made acceptable thanks to the reuse of the existing infrastructure. The tunnel, the underground works, only 2 new caverns have to be made, but also injectors, laboratories, workshops, offices. And above all, the skills of the physicists, engineers and technicians, which is the result of years of experience. Experience, but also tradition. At CERN, individual initiative is encouraged. The hierarchical organization has left room for the coordination of talents. Each physicist has the feeling of participating in a joint project, in which new ideas, creativity and imagination have no regard of age or function. The system encourages brainstorming sessions, which are often improvised. This team spirit results from the indispensable complementarity between the disciplines required to achieve a result. Everyone here feels involved in the same adventure, an adventure which demands absolute perfection from everyone. A single fault in a weld, a single speck of dust in the accelerator, and everything is compromised. Here, a perfect symbiosis reigns between the players in the project, artists who are trying to attain perfection. We should point out that the score is particularly complicated. The LHC is an object which from the outside looks gigantic, but inside you need a deft lightness of touch to install and position the various parts. Prototypes of the LHC were constructed and tested at CERN. The various modules will be manufactured by European industry. Different tests have already proved that the required performances have been achieved and often exceeded. More than 1,000 modules, each 15 meters long, will be lowered into the tunnel via an access shaft and assembled on the spot. The precision necessary for the alignment of the 27-kilometer circuit is of the order of 1/10 of a millimeter. This goes to show that the construction, installation and manipulation of these modules must respond to unusually high demands. One merely has to observe the interior of the machine at various stages of completion to understand its complexity. Superconducting materials, electric connections, liquid helium cooling, a real headache for the engineers. Curving superconducting magnets and their associated cooling systems represent nearly 60% of the cost of the accelerator. The implementation of superconducting materials has required innovative manufacturing processes developed and perfected at CERN, tested and optimized before going into industrial production. Even the welding techniques used in industry have had to be reviewed and adjusted at CERN to correspond to the demands of these machines. In fact, it will be both the prototype and the world's only example. Welding by magnifying glass. A real surprise. This huge machine, whose every piece calls on special technologies, is being made not only by European member states, but also by other countries, such as the United States, Japan, Canada, Russia and India. A unique machine at the disposal of scientists the world over for the physics of the third millennium. All this in order to unlock the secrets of the universe, from the infinitely small to the infinitely huge. Where did we come from? What are we? Where are we going? Soon, no doubt, thanks to the LHC, we shall have the beginnings of an answer.